Yes, children, let us do the numerical questions based on propagation of errors. So already we know that we have studied the formula and the general rules which we have to follow when we do the numerical question based on propagation of error. Different formula, different cases we have studied for addition, subtraction, multiplication and division, and when any quantity depends upon the power of any other quantities. So 5 formula we have studied. So let us do the numerical questions. Now as per the first question you consider two resistances are given. R1 is given 100 plus minus 100 plus minus 3 ohm. Okay. And R2 is given 200 plus minus 4 ohm. The question is to calculate the equivalent resistance when they are connected in series. Okay. So in series combination, class 10 you have studied the formula. Equivalent resistance is equal to the sum of individual resistance, R1 plus R2. So here the value R1 is given 100 plus minus 3 ohm. It means that this R1 true value is 100 and 3 ohm represents the absolute error in the measurement of R1. That is the general rule. In the previous video we have discussed how to represent any physical quantity. Any physical quantity is represented with the true value plus minus its absolute error. So for R2, 200 is the true value, 4 ohm represents the absolute error. So when we calculate the equivalent resistance, as per the formula it is R1 plus R2. So the true value should be added. So 100 plus 200. So true value will be 300 plus minus. Then in the case of addition, when we add two quantities, what should be done with the absolute errors? We have studied in the formula. The absolute errors are also getting added to find out the maximum possible error. So we have to add the absolute errors also. 3 plus 4, 7 ohm. So what is the equivalent resistance? R equivalent is equal to 300 plus minus 7 ohm. Clear, children? Now coming to the second question. As per the second question, you have to find out the temperature difference. Two temperatures are given. Means the initial temperature of the body, T1. T1 is given as 20 degrees Celsius. 20 degrees Celsius plus minus 0.5 degrees Celsius. And the final temperature T2 is given 50 degrees Celsius plus minus 0.5 degrees Celsius. Okay. Now you have to calculate the temperature difference. So temperature difference means T2 minus T1. T2 minus T1. So T1 true value 20 degree, absolute error is 0.5. T2 true value 50 degree, absolute error 0.5 degree Celsius. So temperature difference, this is a subtraction. So as per the formula T2 minus T1, true value we have to subtract. Means temperature difference, the true value is 50 minus 20, that is 30 degrees Celsius. Okay. So true value we got 30 degrees Celsius. Now plus minus. Now what should be done with the absolute errors? So in the formula we have studied, when you subtract two quantities to find out the maximum possible error, we have to add the absolute errors of the individual measured quantity. So here children, you are not supposed to subtract the absolute error. 0.5 minus 0.5 you are not supposed to do. In addition and subtraction, the absolute error should be always added. So 0.5 plus 0.5, that will be 1 degree Celsius. So what is the temperature difference? We got it as 30 degrees Celsius plus minus 1 degree Celsius. I think it's clear, children. Don't be get confused. True value as per the formula we will do, but regarding the absolute errors in addition and subtraction, absolute errors are always getting added. Okay. That was the second question. Now coming to the third question. As per the third question, we have given a rectangular body. Length is given. What is given? Length 5.7 plus minus 0.1 centimeter. Length given, and the breadth given 3.4 plus minus 0.2 centimeter. These are the length and breadth. Calculate the area of the rectangle with the error limits. Okay. So rectangular body, if length and breadth you know, you can calculate the area. True value you can calculate, no problem. So area, we know the formula, area is equal to L into B. So L into B means 5.7 into 3.4. So when you calculate, you will get it as 5.7 into 3.4. The answer is coming is, now I am directly writing the answer, 19.38 centimeters square. This is the true value of the area. Okay. Now when it has been calculated, some errors measured, it has been, errors can be possible. So, and that possible error in length is given 0.1 and in breadth it is given 0.2 centimeter. Okay. So we have to find out the absolute error in the area also. But as per the formula in multiplication, we are not supposed to add directly the absolute errors. What we have studied, we are supposed to add the relative error or percentage error. Recollect, children. As per the formula, delta A divided by A is equal to delta L divided by L plus delta B divided by B. Okay. So delta A, we have to calculate area A into delta L by L. What is delta L here? 0.1 divided by L, the true length, that is 5.7, plus delta B by B. What is delta B given? 0.2 divided by true value of the breadth is given 3.4. Okay. And area already we have calculated. So area you can substitute as 19.38. And from this you can calculate delta A, 0.1 by 5.7 plus 0.2 divided by 3.4, that you calculate and multiply with 19.38. So that calculation part you do, the final answer coming as 1.47. Okay. When you calculate this much, you will get the answer as 1.47. So, and 1.5 nearly you can write. So now how we will write the final answer? Area of the rectangular body, A area is equal to the true value. What we got, the true value? 19.4 we got. So 19.4 plus minus the absolute error. And the absolute error here we are getting it as 1.47. This much centimeter square. So this is the area of that rectangular body. Children, we just true value first we calculated by using the formula L into B. Then the regarding the errors, relative errors are getting added when we multiply two quantities. So that formula we have written and we calculated the absolute error, because as per the question you are supposed to express the area in terms of the error limits. So in terms of absolute error we have to represent, that's why delta A we have calculated. The values we have substituted, and delta A we got it as 1.47, nearly 1.5, and we have written the area, true value plus minus absolute error. Okay. So this is the one example of, in the case of multiplication of two physical quantities. Now coming to the next question, what is given? Resistance formula given, R is equal to V divided by I, resistance of a metallic body, metallic conductor. And what is the voltage given? V given as 100 plus minus 5 volt. 100 plus minus 5 volt. And current is given I. Current is given 10 plus minus 0.2 ampere. Question is, find the percentage error in R. So the question is not express the resistance in terms of error limits. If express the resistance in terms of error limits, what as we have done in the previous question, we will calculate. but the true value here, it is the division. So true value will be 100 divided by 10, that is 10. Then to find out the absolute error, the procedure in the previous question, whatever we have done, that you have to follow. Means delta R by R is equal to delta V by V plus delta I by E. Then we will substitute and we will calculate delta R. But in the question, only we have to calculate the percentage error. So directly you can use the formula. We are not supposed to express the resistance in terms of error limits. Okay. As per the question, only we have to calculate the percentage error. So directly you write the formula, percentage error, delta true value, absolute error divided by true value into 100 is equal to delta V divided by V into 100 plus delta I divided by I into 100. Children, here I is in the denominator, but you are not supposed to write the minus sign here. Remember that. Both in multiplication and division, relative errors or the quantities, whether in the numerator or denominator, we are supposed to add only. Okay. So here it is given directly. It's not directly given. We have to calculate percentage error. Delta V. What is delta V? 5. So 5 divided by 100 into 100 plus then delta I. Delta I, that is 0.2 divided by I, the true value is 10 into 100. Okay. So 5 by 100 into 100, 5% plus this 0.2 into 10, 2 means 7%. So here directly we calculated the percentage error in the resistance. We got it as 7%. Just we wrote the formula, we substituted the values and we got the answer 7%. Okay. Coming to the next question. As per the question, what is given? Percentage error in mass and speed given. Percentage error in mass, matlab delta M divided by M into 100. This is given as 2%. And percentage error in speed given 3%. So delta V divided by V into 100 is equal to 3%. Directly given. What you have to calculate? Find out the maximum error in the calculation of kinetic energy. Okay. Percentage error is asked. Percentage error in kinetic energy. So percentage error in kinetic energy. Percentage error in any quantity, how we will write? The absolute error divided by true value into 100. So delta K is the absolute error in kinetic energy measurement by K is the true value into 100. Okay, this is equal to, and kinetic energy formula all of you know, kinetic energy is equal to half mv square. So half is a constant, you are not supposed to bother about this half. So half we can leave. Then mass. So percentage error, first delta M divided by M into 100 plus. Now V square. So we have studied the formula regarding the power of the quantities. Remember children? So that power dimension 2 into delta V divided by V into 100. Okay. Children, normally students used to forget to put this dimension. Don't do the mistake children. Okay. So this delta M by M into 100, it is given 2%. So 2% plus 2 into delta V by V into 100 is given 3%. Okay. So 2% plus 6%. So what we are getting? 8%. So the percentage error in the calculation of kinetic energy, that is 8%. Okay. Simple question. Children, clear I think. Now one more question we have to do. The next question is one physical quantity is given. X is equal to a square b cube divided by c into root d. Okay. And what is given? The percentage errors in the measurement of A, B, C, D. A, B, C, D percentage errors are given. How much given? 4, 2, 3, 1. 4%, 2%, 3%, 1%. you have to calculate the percentage error in x. So percentage error in x, first let us write the formula. Delta x by x into 100 equal to, first quantity is a square. So power is there. So 2 into delta a by a into 100 plus. Next is dependency is b raised to 3. Dimension is 3. So 3 into delta b by b into 100. Okay. Then the denominator, two quantities are there, two dependents, c and root d. So, but we know that even though the quantities are in the denominator, you are not supposed to subtract. Again, I am reminding you children, again it will be plus, not minus. Then c to the power 1 hai dimension. So, delta c divided by c into 100 plus root d, you can write d raised to half. So, there the power is half. So, half into delta d divided by d into 100. Okay. So, 2, now percentage error in the measurement of a means delta a by a into 100, that is directly given as 4%. So, 2 into 4% plus, now 3 into percentage error in the measurement of b, directly given, absolute error is not given, percentage directly given, means delta b by b into 100 is given as 2%. So, 2% plus delta c by c into 100, percentage error in the measurement of c is given 3%. So, 3% plus half into delta d by d into 100, mean percentage error in the measurement of d, that is directly given as 1%. 1%. So, what will be the final answer? 2 into 4, 8, 8 plus 6, 8 plus 6, 14, 14 plus 3, 17, 17 plus half into 1, matlab half. So, answer, final answer coming is 17.5%. Okay children, don't be get confused. Again I am saying, normally students used to, the two mistakes generally students used to do. One, they used to forget to put the dimension. Okay. And one thing, when the quantities are in the denominator, students used to write, instead of plus, they used to write minus. So children, don't do the mistake. That's why again I am saying. Okay. Now, as per the last question given, the time period of oscillation of the simple pendulum is given. Time period formula is given, t is equal to 2 pi under root L by G. When formula is given. And the measured value of length of the pendulum is given 20 centimeter. So, length is given 20 centimeter. Then it's known to 1 millimeter accuracy. So, known to 1 millimeter accuracy, that means delta L is given 1 millimeter. Okay. But children, here length is given in centimeter, so we are supposed to express delta L also in centimeter. So, 1 millimeter we can write it as 0.1 centimeter. Okay. Then what else given? Time for 100 oscillations of the pendulum is found to be 90 seconds. So, what is the time given? 90 seconds. Okay. And using the wristwatch of 1 second resolution. So, 1 second resolution means, the meaning is that the absolute error in the measurement of the time, that is 1 second. Okay. So, here children, separately no need to find out the time period, time for one oscillations and all that. That when you find out that for one oscillation means 90 by 100, the same thing you will have to do with the delta t also. So, that is automatically that will be getting cancelled. That is why directly I have written 90 second and 1 second. Okay. Now, what is the question? What is the accuracy in the determination of G? Means you have to calculate, the meaning is that you have to calculate the errors, percentage error you have to calculate in G. So, we need the expression for G first of all. Expression for time period is given. From that we have to write the expression for G. So, let us square on both sides. T square is equal to 4 pi square L by G, or G is equal to 4 pi square into L by T square. Okay. Now, we can write we got the formula. So delta G by G into 100 percentage error in G is equal to 4 constant, pi constant. So we are not bothered about that 4 pi square term. Next is quantity is L. So delta L divided by L into 100 plus. Then next dependence with the time period T square. So what we will write? 2 into delta T divided by T into 100. Clear, children? Now just substitute. Delta L is given. Delta L what is given? 0.1 divided by L. L is given 20 into 100 plus 2. Delta T is given as 1 divided by T is 90 into 100. Okay. So we have substituted the values given as per the given question. So when you calculate this, you will get it as, see that, so 5.1 into 5, 0.5, 0.5 plus 2 into 10, 20, 20 divided by 9, and you will get it as 2.22. Okay. So final answer what we are getting? 2.72%. The accuracy in the measurement of G is 2.72% or nearly 3%. Okay. So it's a textbook question, children, very important. Hope all the questions are clear for you.